In terms of soft skills, I would say it is mostly your communication skills. The industry works from the point of profit and loss. The academics is more of an idealistic scenario, and industry is more of a real life scenario.
Hello everyone, my name is Prateek Mohanty. I am your host for today's episode of KIITians Unplugged. And today we have with us Dr. Suvan Dev Choudhury, distinguished alumni of KIIT University, whose journey truly reflects the global impact of KIIT education. Dr. Choudhury began his academic foundation at KIIT School of Mechanical Engineering, went on to pursue his Ph.D. in Material Science Engineering from University of Alberta, and is currently here making remarkable contributions both in academics and industries. He serves as a lecturer at Red Deer Polytech, Canada, teaching subjects like material science, welding, and failure analysis, while also working as a mechanical engineer on advanced industrial and research driven projects. From classrooms at KIIT to research labs and engineering industries in Canada, his journey is an inspiration for every aspiring engineer sitting here today. So I would like to welcome Dr. Suvan Dev Choudhury.
Hello, Pratik. Thank you for having me here. It's a pleasure.
So before we begin, Bhaiya, how is everything going in Canada?
Well, I would say life in Canada is simply awesome. It can, it's, I'd say, one of the best lives I've been living. Um, yeah, quite different from India, but then, at this point of time, I'm pretty used to it. But it's pretty good.
Okay, so how have you been balancing both industry and academics in Canada?
Yeah, it's a mixed bag, honestly speaking. Not the easiest job out there because I am working full time as a R&D engineer in one of the oil and gas companies in Alberta, and also working as a lecturer, that to a sessional lecturer taking multiple courses. It's a bit of a balance, but then I would say the knowledge transferable is it's knowledge transferred skills. You can use both of your knowledges. It's not like I'm doing two distinct work, but overall, I'd say it's a fine balance that needs to be created, and hopefully, I'm able to do it. It's been that's a second year of teaching, so yeah, it's going pretty good now.
Okay, so after so many years, how do you feel like your own college recalled you to this podcast show?
Well, honestly speaking, it's a privilege being here because when I was a student, this podcast thing wasn't there. It wasn't a thing. But at that point, I know certain of our seniors would be coming, visiting us in person, coming to our classes, and then teachers would be praising them. And deep inside, I also wanted to be in that position. And today I feel very humble that at least I am at that position where our professors are reaching out to me for this podcast. And honestly speaking, this is a very good opportunity to for me to at least give some advice to the next generation or the next upcoming engineers, give my experiences so that they can decide better.
Okay, so Bhaiya, you made a major life and academic transition, like moving from India to Canada. So what are these transitions that came in your academic, professional, and personal life?
Multiple challenges happened during this entire period. First thing is it's a different country, different culture altogether. So, getting accustomed to this culture, assimilating up here was a big task. Uh, because at the end of the day, I'm staying here for more than half a decade at this point, and if I refuse to assimilate, I would not be able to be living happily. So at this point, I've assimilated. That is one cultural thing, or one cultural aspect, if you may want to put it in that way. Apart from it, in terms of academics, it is quite different than what we are used to in India. There are some pros and cons, but then I would say one of the major differences, not a challenge, but a difference up here is the professors expect you to figure it out. In India, professors are there to help you it's not that professors are not helping you out, but then they want you to brainstorm the ideas, come up with new things. So that is one of the biggest challenge, have rewiring your brain in a way that now you are more of a problem solver than a prof giving you a problem and then you solve it. So you have to first identify the problem, and identifying is one of the biggest things. So that was one of the main challenges. Transitioning to a job was not that bad because I already was accustomed with the Canadian job market because of the PhD program. 4 years I was working for a company who was my PhD sponsor as well. So already knew what to expect, but then the first or 1 or 2 years of academics was a big challenge. But once I understood the game, it wasn't that bad. Things were pretty smooth after that.
Okay. So, like, what were the initial challenges? Like, when you first reached Canada for your PhD, like,
Mhm.
where do you stay and like food and everything?
Yeah, so there were those initial challenges where finding the right apartment or finding the right house. Food was again another thing. Although, good thing with Canada is that there's so many Indians out there. We literally have Indian groceries where you can find Maggie, Parle G, everything. So food wasn't a big deal, but cooking my own food was a new experience, and cooking it almost on a consistent basis was a new experience because we are not used to that in India, not during our stay in KIT, right?
Yeah.
Uh, Studies as a whole was a bit challenging because first year of PhD you have to complete your courses, at the same time you have to also start off with your research. So balancing both, along with balancing my day-to-day chores like cooking food, doing my laundry, washing dishes. So those were the things which I had to get accustomed with. But once I was pretty much comfortable with those scenarios, life became a bit easier.
Okay. So let's get to the beginning. Like, Bhaiya, why did you choose mechanical engineering? Like, was it a trend that time? Like,
uh,
now it is CSE and mechanical at that time?
No. So at that point, CSE was the trend, and believe me or not, but I joined KIT in electrical and electronics engineering for my
Okay.
first year, and then I switched my branch to mechanical. The reason being is that when in first year of engineering, like you might know, I believe you have graduated first year now.
Yeah.
Okay, so in first year of engineering, there is this lab, I think basic manufacturing lab,
Yeah,
if
yeah, yeah.
I'm not wrong,
Workshop,
BML.
we say. Yes.
Yep. So you have to do welding, you have to do sheet metals, soldering and stuff. That when I first experienced that, I knew that this was my thing, and at that point it was like a one step decision. I didn't think twice. My GPAs were good enough where I was able to switch my branch, and I just did it. So mechanical wasn't a trend, but I really loved the subject, I really loved the course. And yeah, and at this point I think that's the best decision I have ever made. My parents were
Okay.
not happy that I choose mechanical because, again, in terms of job opportunities, it's not the best. But then, that's something what I really loved.
Okay. So means you were like you first stepped into workshop and you saw welding and
Yep.
all those stuff and you like, oh
And
my God, this
yeah,
I'm
and
gonna
as a
join
child,
this.
I was always fascinated with cars, with any
Yeah.
sort of mechanical equipment. So I always had that affinity. But when I saw mechanical engineering in practice, I realized that no, this is the field I should be going into.
Okay. So you set a mindset of being a mechanical from your second year, like right?
No, no, I would say second semester,
Oh,
which
second
is first
semester.
year itself. Yeah,
Okay.
yeah.
So you said you chose electrical and electronics, right?
Mhm.
So you had interest in those or you like just joined it?
At that point I wasn't aware. It was solely based on some of the advices that probably my parents or my family members or people who are in this field of computer science, electrical, electronics, because it is more related to coding, and that is the trend still going on at this point. So it is based on people's advice. I wasn't aware what was the best decision, but then once I got into the courses, I did the classes, I was very confident that mechanical was the way to go.
Okay. Okay, good. So, so from second year you started with mechanical course, right?
Yep.
So what were the best memories of your labs, and in second year we have advanced manufacturing lab.
Yep.
So
Uh, yes.
you
So
want to say anything about those things?
In terms of labs, it was very interesting because in second year, again in KIT does a very good job at that, where the professors make the student aware that apart from your course curriculum, you should be also involved in other activities so that you can uplift your skills, develop other skills that is necessary for the real life work environments. So I was aware that I should be doing something else apart from my regular courses. So I did try my hands into the harms racing, I believe, that team. So I went to their meetings, but that was something which didn't spark much interest. And at that point, I happened to meet one of the best profs of my life, Dr. B. Surekha. So she did have a PhD student under her supervision at that point. So I just approached her saying that, hey, you are teaching us material science course. I really like the course. Is there something that I can get my hands into? Maybe start off with some research work or something. Because again, I my father was a bit aware of the research scenario. He did advise me that, hey, you can give that a shot, see if you like that. And I approached her, things worked out. Yeah, and then ever since second year I was into research then completely.
Okay, so uh, so this so what brought your interest into these research? Like directly you when you talked to B. Surekha ma'am, or you had something other studies or any that material science subject that we have in second year? Did that pull your interest?
Yep,
Or
the material science subject itself pulled my interest.
okay,
Normally, material science came very naturally to me. Like there would be certain subjects like which would be very very natural to you.
yes,
Material science was a subject which came very natural to me, and again, like I was fortunate enough to have Dr. B. Surekha because her way of teaching was something which resonated with me, and I developed some deep interest in that core in that subject. Although my peers were some of them were not very interested, but for some reason I was very interested and I was pretty good at that subject. So that sparked my interest. And also it is more of compatibility with your supervisor, right? Like I somehow was compatible with her, and maybe she was compatible with me as well as a student, so it worked out between us as a good student teacher relationship. So
okay. So I saw in your CV your final year project was EDM
yes.
machining of aluminium and magnesium alloy. Like,
Mhm.
so would you like to elaborate it about?
Yep, totally. So before that final project, I was fortunate enough to publish couple of papers in EDM, because EDM was available in our department at that time, and Dr. B. Surekha got her hands into EDM. So that was very natural to get into that. And EDM is just a manufacturing process at the end of the day, but what you want to achieve out of EDM, that is the big question, right? So for me, like although in the second and third year I did work on the EDM, we published some good papers, but I wanted to do something different for the final year project. So the narrative of the magnesium aluminum alloy was making a lightweight alloy. So we did our own castings on campus in our machine shop, and we made alloys of different compositions, and we did EDM machining to see which alloy would be the best in terms of weight to machining compatibility. So I think that was the basic narrative at that point, but I just wanted to do something new with EDM. So did our own alloys, we machined it, we had a good understanding of it. So that's how the final project went.
Okay. So Bhaiya, apart from material science, what other subject you got your interests in? Like, was there any second subject something?
Uh, yeah, there were other subjects like manufacturing processes was something which was very interesting to me. Um, at that point, although simulation was a thing, but it wasn't that popular. But that also sparked a bit of interest because with the strength of materials, you want to know how much stress the material can endure. So those were the topics which sparked interest. And fortunately, during my PhD, I mostly worked with all these topics, and that gave me a very good understanding of what I'm looking for.
Okay. So, so now looking back, how do you see the transition from a mechanical engineering student at KIT to a material science researcher and engineer in Canada?
The transition was very seamless. It wasn't a big transition, although material science itself is a own engineering degree in India.
Yeah,
In KIT, it wasn't offered at that point. I'm not sure if they're offering now, but at that point, there was no materials engineering as a B.Tech course. But material science, whatever we did or whatever we learned in our second year of material science course, that is not enough. There's so much into it, thermodynamics, making phase diagrams and stuff, and also understanding different mechanisms of how a carbide would be forming in different steels. And so it was a big transition because, again, it those were two different disciplines, but although coming all derived from mechanical. But doing a PhD and taking those material science specific course wasn't the easiest. I had to put a lot of time and effort to finish my courses at that point. But I would say there is not many gaps, but it wasn't the easiest at all. So you have to put the time and effort, but it is still doable.
okay. So now I would like to ask about some soft skill. Like, how do you gain the soft skills? You said about Hermes Racing. It is one of the great societies of our mechanical school. Like,
Yep.
did it help you with some soft skills and
I
something?
wasn't involved with them. Uh,
Okay,
Honestly speaking, I just went for 1 2 meetings and it didn't spark much interest, so I just ignored that.
okay,
But in terms of soft skills, I would say it is mostly your communication skills, because if you're not able to express yourself, what is the point of doing all this stuff, right?
exactly.
And what developed my soft skills was all the conferences I went during my B.Tech years. So when we published the papers, B. Sureka ma'am gave me the opportunity to go to conferences and present our research there. That also helped me, gain this speaking ability, I would say, and expressing myself in a very clear and concise way so that all the audience can understand me. So that helped me a lot, I would say, mostly the conferences at that point. And also, again, in Canada, once you come up here, uh, it's an English speaking country. You have to speak in this language. You stay here long enough, and
Yeah,
English will be very natural after that. So
yeah. So like so in Canada, when you first you established your everything and you were settled, what were the what challenges you faced when you started working with multidisciplinary teams? Like in engineering background, you like worked as an engineer and then academics you need to work as a lecturer. Like what was the transition and what changes you had?
Um, I would say when you're working for industry, uh, one of the important things that I learned was finances, because every industry works from the point of profit and loss. That is the basic thing. If you do not care about it, you will not be able to sustain in an industry. And second thing is customer relations, because again, industry is selling their products to their customers. Either you're talking to your vendors or you would be talking to customers. In my situation, because I work in the R&D, I am not selling anything, but I am talking with our vendors a lot, because we have to get the most competitive price up here. If we are outsourcing a job, we have to also look into the labor cost and everything. So price, as well as your vendor relationships, was a big transition from academics, because in academics you mostly care about the research, and money is not the I would say, it is one of the factors, but not the most important factor in an industry. Money is one of the most important factor, how much you're spending. And if you have overspent, then you have to explain to your bosses, like, why did you take that decision, what was the rationale. If your rationale was is not good enough, you would be in trouble at that point. So that's something that I had to learn coming to an industrial setting, but that is something I think is very important as well, because that is your real life, right? A real life scenario. I would say academics is more of an idealistic scenario, and industry is more of a real life scenario. And at this point, I'm having both these jobs. Like I am working part time as a lecturer, I'm working full time as an R&D engineer. So I have a good understanding of both the worlds now. But I'd say that that was the main challenge for me to even grab. Like, okay, this is what the industry needs.
So, according to you, soft skills like communication, money
Yep.
management, and
Yep.
personality. What else do we need to sustain in this industry and academics both?
Taking ownership of your decisions, because in an R&D you are mostly independent there. Although you'd have a R&D manager, but they would assign you a project and you have to take ownership of the entire project. So taking ownership of your decisions, having a good rationale of why you're doing stuff, that is important. When you go into academics as a lecturer, now you are a mentor for 20, 30 students, right?
Yeah,
And they would look up to you. So uh, your communication, your way of expressing, your way of dealing challenging situations has to be at that level, or else, like, if you behave as a student there, that's not gonna cut it, because students are looking up to you, right?
yeah.
So again, these are two different roles, and again, playing it at the same time took a bit of adjustment. But once I understood that this is the crux of a R&D engineer, that's the crux of an lecturer, so things became easy after that.
Okay. So, apart from college and other skills and stuff, let's talk about any memorable experience of yours from like any workshop, lab, hostel life. Like, were you a hostel boarder
Yep,
or day
yep.
boarder?
No, I was a hostel boarder.
Okay, so any memorable stuff from hostel?
Yeah, but after, I'd say after work, we would mostly go to gym. We will go to play. What sport did I play? Oh, badminton. Yeah, badminton was something very good. My roommates were fortunately very good roommates, and everybody, three of us were under Dr. B. Sureka. We did our research together. Our final year project was done together, so it was
Yeah.
always a fun activity. And we would be studying together, we'd be going to eat our dinner, lunch. It's like best friends forever kind of thing at that point. So but I'm still good friends with them, still in contact with them. But fortunately, with good roommates and good friends around me, yeah, it was all the co-curricular activities, like going to the gym, or maybe going for a run in KSRM,
Hmm.
or going out just to have some food, because food in Bhubaneswar is cheap. So
Yeah. So, bhaiya, this is my personal question. Like when you are into a lecturer, when you change into a lecturer from a engineer, do you sometimes feel like when you're teaching, do you get that thing in your mind like, oh, I'm teaching this way. I was used to like that faculty used to teach me this way. Like, do you have that factor of those
yep,
faculties in you?
yep. Those connection points always came, because uh, everybody has a different way of teaching, and I would say at this point, my way of teaching is a mixture of all the different profs that I have ever encountered in my life. And yeah, whenever, say, I am repeating, so with material science, like always be Dr. B. Sureka's lectures would come to my mind. The way she would be doing the FCC crystal structure, BCC crystal structure,
Yeah.
yes, it always comes to my mind. And up here, mostly I would be building slides for them and be doing a lecture, but then also going to the whiteboard and doing those questions with them, especially with the different, say, orientations of FCC, BCC. Students find it difficult to visualize, but if you draw it out, that's how Dr. B. Sureka would be doing back in our days. Uh, that always sparks those good memories, for sure.
Okay, so we talked about soft skills. Now, from your current experience, can you please tell me what technical skills a mechanical engineering aspirant should have?
Honestly speaking, at this point, if you look at a global scenario, mechanical engineering is not only mechanical engineering. At this point, it is a mixture of everything. Um, if you think from an industrial perspective, all the industry cares about is you solving the problem.
Okay.
For you to solve the problem, if you need to learn electrical drawings, you have to do it. If you need to learn how to say program a certain electronic component, you have to do it, because at this point nothing is completely analog mechanical that used to be before. It is all coupled with electronics, right? So having an understanding and having an open mind uh, towards those different disciplines, that helps you a lot to grow in this industry. Because as I said, industry doesn't care if you're mechanical, they only care that this is the problem that needs to be done, and how you solve it, it's up to you.
Yeah.
That being said, as a mechanical engineer, you are always expected to know your basics very well. So you have to be very, very, I'd say, thorough about your core basics of mechanical. At this point, you have the internet, you have Chat GPT, you can always look stuff up. But having an understanding, like if you do not know what principle you'd be using for that particular, say, scenario, how would you even search for it, right? So at least knowing the big overview and knowing what to use where as a mechanical engineer is something you have to develop. If you do not develop that, it is pointless to be a mechanical engineer then.
Okay, so you mean like with mechanical, we need to study all other disciplines around, like,
You do not need to study, like, I would say, actively. You can do it passively as a problem comes up. If you need to know, have an understanding of that, you just study that. So you do
okay,
not need to study actively, because again, at the end of the day, what matters is that you are able to solve the problem. That's all it matters. So
okay,
yeah, even if you need to learn Python for that particular problem statement, you have to do it. That's all.
okay. So now let's talk about so what so coming to an end of this podcast, what are the advices you would like to give to the students sitting in our college right now, like the batchmates of mine and your
Yep.
juniors?
Um, at this point, I think you guys are old enough to know what is good for you, what is bad for you, what you need to be putting your time and effort into. So I would not be lecturing you about that. But what I would say as a life experience, that is something what I've implemented in my life, is do not follow the masses. Because as you said, right, computer science is a trend. I will never say that computer science is good or bad. It is just a discipline. It's not like mechanical engineers cannot earn a living. Mechanical engineers also can earn a living. Its only thing is that follow what you think is correct. I followed mechanical engineering. It worked out for me. I did my PhD. Now I am in both the worlds doing stuff. And that's what, like, I did not listen to what the trend was at that point, because trends would come and go. But you have to know what you think is correct, because at the end of the day, if you say become a computer science engineer, it's not like you'd be earning so much money if you do not understand it, right? So same goes for mechanical engineering. You have to understand. So understanding would come if you like the subject. If you like the subject very deeply, you will be good at it very naturally. You do not need to put time and effort. And honestly speaking, I have been studying since the last 8 years, 4 years of B.Tech, 4 years of PhD, and I enjoyed my time. Yes, there were difficulties, there were ups and downs, but I would never ever trade mechanical engineering for any other discipline, because that is something what I truly believed in, and by God's grace, it is working out for me. So yeah, do not follow the trend. Just do what you think is correct. That is the most important thing, because at the end of the day, uh, the more time and effort you put in one thing, you'd be better at it. But if you put time and effort in everything, it's you'll be like what's called a jackal of all trades, master of none. So
Yeah.
I would not suggest you that.
Okay. So any pathway would you like to suggest for the students who want to do further research after B.Tech?
Depends on the interest, honestly speaking. But from mechanical engineering, there are a couple of things I would say. If you can get your hands into FEA simulation, CFD, structural FEA, do that. Learn Python, because Python is not only coding, but it's just a tool, just like MATLAB, right? You'd be using that for your mechanical stuff as well. Like if you have a large set of data, what did you do? You have to use Python. You cannot do everything in Excel.
Yeah.
So learn Python, get your hands into FEA, do that. Uh, what else? Another thing is always develop good communication skills. It doesn't matter what language you're communicating in, doesn't need to be English, but you have to be able to express yourself in a nice way. Another thing I'd say is, as an engineer, you are always expected that you know the technical words for those particular things. I've seen many students who knows what they're speaking about, but they cannot get their words put together, the technical words. So that
Okay.
shows that you did not put much time and effort into your subject. So having that understanding would be good. So
Okay. Okay. Thank you, Bhaiya. Now let's do a rapid fire round.
yeah, totally.
Okay. So one word to describe your time at KIT.
Transformative.
Okay. So one subject from mechanical engineering that truly shaped your thinking.
Material science.
Okay. Research, industry, or teaching. Which one would you like to choose? One of three.
uh, well, tough question, but I chose both of them, honestly speaking. But yeah, if
Okay.
I had to choose one, I would choose teaching because that is more fulfilling. Yep.
Okay. One skill every mechanical engineer student must master before graduating.
Communication.
Okay. And one last one. Uh, if you weren't a mechanical engineer and lecturer, what do you think you would be today?
I'd be an entrepreneur. Maybe I'd be. If I'm not a mechanical, yeah, I'll be doing my own business for
Okay.
sure.
Okay,
Yeah.
good one. So, so with this, we come to an end of our podcast, Priya. Thank you very
Awesome.
much for
No,
joining
thank you
KIITians
for
Unplugged, and your journey at KIIT University to research, industry, and academics in Canada is truly inspiring and offers a powerful takeaways for every engineering students. So,
yeah. No, thank you for inviting me. That's truly a great honor, and I always wanted to be in this position where at least I am able to give an advice to other students. So yeah, that's great.
okay. And to all our listeners, whether you are a student, an alumni, or an aspiring engineer, we hope today's conversation motivates you to stay curious, build strong fundamentals, and confidently explore opportunities beyond boundaries. Thank you.
Awesome. Thank you so much, Pratik. Talk to you soon.